Right, we had exercise 2.1. So let's see. The first one, they asked me which one of these two numbers would be greater. And then you've got two negative numbers. Remember that the one closest towards the 0 would be the bigger number. Okay. So look at A and B. Then at number 2, which number is smaller in these pairs? Not the first one, A. Pick up. Who's that? What did you do there?
We talked about something.
What? Matt.
Something like that. Also, if I can come over.
Don't you understand what's going on?
I do understand, but you know what, sometimes it's just like, go push
Right, so at number 2, which number is smaller in these pairs? Now over here, I also have two negative numbers at the first one. So smaller means the further I move away from the 0, the smaller that number will become. So between the negative 68,000 and the negative 69,000, the negative 69 will be even further away from the 0, right? So that's why that will be the smaller one. Then at B, between 0 and minus 1010, obviously the negative number will be the smaller one. Okay, right. Then 3A. Arrange these numbers in ascending order. Now, yesterday we said when a plane is ascending, it goes up. So we want it from the small numbers to the big numbers. So that's why we start with our negative numbers first. So minus 12, minus 9. Then we get to 0, and then 8 and 10. Right, then B. Also from the small numbers to the bigger ones. So we start with our negative numbers. So first minus 70 Rand, then minus 36 Rand, and then 192 and 305. Any questions there? You guys good? Okay, then number 4A. Arrange these numbers in descending order. Now descending means it's going down. So I start with the big ones and then I go towards the smaller numbers. So at 4A, you're going to start with 1. That was the only positive number. Then 0, and now we've got to look at our negative numbers, and we go from the ones closest to the negative, closest to the 0, and then move further and further away. So that's why we first have minus 2, then minus 17, and then minus 19. Okay. Then at B, remember it's descending, so biggest number here, they're all negative. So the biggest one between all of those negatives would be the one closest to the 0. Okay, so that's why I start with a negative 51,270. And then we go to negative 68,000, negative 71, and then negative 109,000. Okay, any questions there? Okay, can I skip? No one's still copying? Okay, then number 5. 5A says calculate the value of the expression when x is minus 1. So 2 days ago we said whenever we substitute in, it's very important that we have to keep it in brackets. So you will see that everywhere where we had an x, I now put in brackets minus 1. So and you simplify that, and that gives you minus 6. Okay, then at B, what if x is minus 2? So same thing, but when I substitute it, put it in brackets and say minus 2 everywhere that we had an x. And your final answer there would be minus 1. Do you guys understand the substitution?
Yes, ma'am.
Okay. Then C, x is 0. So instead of x, I'm going to write 0, but we still keep it in brackets, which means that my final answer there will be minus 5. Okay, then number 6. says the temperature in Moscow was 2 degrees Celsius. Then it dropped 8 degrees below 0. By how many degrees did the temperature drop? Okay, so it started with 2. Then we know it dropped. That's why I have a minus. And it dropped to 8 below 0. So that's why I have minus 8. Do you guys understand that? Okay. Now what I want you to see is that these two negatives will then become a plus that we have here. And that's how I got to the 10. Good. Okay. 7a. Which temperature is lower? Minus 9 or minus 10? Minus 10, that's moving further away from 0. Then between minus 25 and minus 52, it would be the minus 52. Okay. Any questions there? Okay, can I skip? Number 8. Mount Everest is 8,848 meters above sea level, and the Dead Sea is 400 meters below sea level. What is the difference? What does difference mean again? Minus. Difference between the two elevations. Okay, so we start with the 8,848, and because it's difference, we're going to say subtract. And the other one was 400 meters below sea level. So that's why I have the minus 400. Now again, these two minuses is going to give you a plus. Which means just 400. Yeah. Okay. Just think of it if this is like the ocean and that's the hill. So this okay, and the Dead Sea is here, 400 below sea level. So you first got to go the 8848 and then another 400 to get to there. Okay, that's why the difference is so much bigger. All right. Number 9. Mercury has a melting point of minus 39 degrees Celsius. And the freezing point of methanol is minus 98 degrees Celsius. How much warmer is the melting point of mercury than the freezing point of methanol? So you'll see that I start with a minus 39 degrees. And I want to get the difference between the two, so I'm going to minus. And then the freezing point for methanol was minus 98. Now again, these two negatives are going to form that positive or make it a positive. And then if I add that, it means the difference between them would be the 59 degrees Celsius. No. It's 59 degrees warmer. So it's a positive. Good. Okay, number 10. The Dow Jones average dropped from 12,837 to 12,503 in 1 week in June. Calculate the drop in the share index. So all I had to do is go subtract those two from each other, and that gave me the 334. Now at B they're saying, if the price continued to drop for another 4 weeks at the same rate, calculate the Dow Jones average after those 4 weeks. So it already dropped from the 12,837 to 12,503. So that's where we're going to start. 12,503. Now it's going to drop, so it's going to become less. 334 per week, but it's 4 weeks. So that's why I say 4 times the 334. Do you guys all understand that part? Okay, I didn't write out the step in between. I just skipped directly to the answer saying it would be 11,167. Do you guys all understand?
Yes, ma'am.
Okay. Right. So what we're doing now is we are looking at the properties of integers. Let me see, who's still copying here? Now what? Okay, let's see. Like terms. What are like terms? Like terms means that their unknowns or their variables is the same, right? Okay, so if I were to give you this, 4x and 3x, would they be like terms? Yes, because their unknown, the x, is the same. No. Okay, so you don't have to look at the coefficient over there, the 4 and the 3. I know they're not the same. But the unknowns, the x and that x, they are exactly the same. So therefore, they are like terms. Okay, the next one, I'm giving you AB and BA. Would they be like terms?
No, ma'am.
Okay, so what is it, a no or a yes? Okay, let me ask it this way. Do both of them have A?
Yes.
Do both of them have B?
Yes.
So are they like terms?
Yes.
Yes.
Because two variables plus two
Okay, listen.
before.
Listen. Even though it was shuffled, even though it was switched around, AB and BA is the same thing. So you can say they were, oops, Nina. Yeah. Ek wil nie van die kant af gaan nie. Okay, so A, B, and BA, they will be equal. Okay, even though it was swapped around, because what's actually written between that A and that B is a multiplication sign. No, it's actually A times B. And when we multiply, order doesn't matter, because not the bananas, but 2 times 3 gives me 6. Let's swap them around. 3 times 2 still gives me 6. No, so order doesn't matter when we multiply. Okay, let's look at the next two, these two. X squared y and xy squared. Are they like terms?
No.
Who wants to explain? Oh, okay, first. Who wants to say whether they are not? Yeah.
Maybe they are not because it's x to the power of 2 times y.
Yeah?
X times y to the power of 2.
Okay, so in the first one, I've got x times x. That's how we get x squared, right? And over here, I just have x, and I'm supposed to have 2 of them. So can you see they're not the same? Let's look at the y's. Over here, I've got y, so how many? Just 1. Over here, I've got y squared, which is actually y times y. So can you see that these are not like terms, not equal? Okay. Right, let's look at the blue one. 3x squared y and 3x bracket xy. What's actually written here? Times. So it's 3x times xy. So who wants to take a chance and say, is it like terms or not? He's saying it is. Okay, so who says that it is like terms? Okay. Who says it's not like terms? Okay, put your hands down. Put your hands down. We've got 2 winners. Huh? Because, listen, over here, listen, I'm going to explain. I'm just waiting for you guys to quiet down. Over here, we said that's actually 3x times xy. Okay, so what is x times x? X to the power of 2. What do we have here? X to the power of 2. Then over here I've got a y, and have a look. Y. No, the x is multiplied with that. It's the same thing. It's like x times y. And then it becomes x squared y. Do you mean, I'm just, grade 9, grade Kazi, people, I love it when you take part in the lesson, but like now, we're not working together. You guys are going on with your own thing, and then that is not nice towards me, and then also we're wasting time. Okay, so it's not going to work if we do that the whole year. Okay, to answer your question, it's not like you multiply the x with that and with this. Okay, because what's actually written there is 3 times x, because that's these two, and then times x times y. No. Do you get that part? Because there's a multiplication sign here and a multiplication sign there. And actually between these two too. Whenever we write two unknowns next to each other, it's like saying we actually multiplying those two. Do you agree? Okay. Now when we write it out like I've got it on the right hand side, like this, then you can see that if I put those two together, the 3 will stay 3. The two x's, the x times x will become x to the power of 2, and the y. You are multiplying it in. They're all multiplied with each other. Like we have over here. Okay? Right. So would that be like terms then? Yes. Okay. Then the last one. 2a squared b and 2ab squared. No. You can see that in the first one, over here I've got a squared, and over there I only have a. Over here I've got b, and there I've got b to the power of 2. So that's why they're not the same. Their variables aren't exactly the same. Now, why do I go through all these like terms? Because when we simplify, only those that are like terms, I can go and add and subtract. Multiplication doesn't matter. You can multiply any term with any one. But when it comes to plus or minus, you can only add or subtract those that are the same, meaning those that are like terms. Okay, right. So, before we go and add and subtract, oh glory, hierdie ding wil nie vandag werk nie. Now there we go. Okay, minus 5xy squared. That minus 5, and you'll see I include the minus as well, not just the 5. The sign must always be included. That sign is part of the 5. Okay. Right, so minus 5 is written in front of my variable. And what do we call it then? That is a, there we go, a coefficient. Remember, in the test, if I ask you for the coefficient of xy squared and you just say 5, you're not going to get your mark. You must say minus 5. The sign must be included. Okay. Right. So let's look at a few examples. If I were to give you minus 5xy squared plus 6xy squared. Now, because we see a plus, I first had to think, are these two like terms? Yes, they are. They've got the same unknowns or the same variables. So I am allowed to add. Now, because they like terms, we can just look at the coefficients. So minus 5 plus 6 gave me 1. And now what about the variables? They stay the same. And that's where the apples and bananas come in. If I've got, I'm going to do a different sum because I don't want to work with minus bananas. So if I've got 6 bananas and I say plus 2 bananas, I now will get 8 what? Still bananas. It doesn't change to apples all of a sudden. So when we add or subtract, variables stay the same. Okay, it stays bananas, yes. All right, it's only when we multiply or divide, then the variables are going to change. Okay, right. So the next one, minus 22 ABC plus negative 14 ABC. First things first, are these like terms? Yes, they both have an A and a B and a C. So I am allowed to go and simplify. Now, I've got a plus and a minus next to each other, so that would be your first mark to go and change that. And that will become minus 14 ABC. And now it's a normal adding and subtracting. So minus 22 of that minus 14 of those will give me minus 36. And have a look, unknown stays ABC. The variable did not change. Okay? Can I skip? Okay, okay. Can I skip? And okay. City. Who sits here? Andy, not here. Oh, yeah, I said, oh. And then who sits here? Oh, okay. Okay, okay. And then Ashik, Theo, Chandra. Oh, Chandra, Raphael, Nilan.
Yes, ma'am.
Huh?
Nilan.
Why aren't you here? Did you ask me? Skype, 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 Skype.
Skype. Nilan Skype.
Funk. Wade. Tristan. Ivatni. Tomika. Grantham. Nabil. Kazi, where should you sit? Is it just because Nabil isn't here? Shakila. Mukta. Fiso. Leabua. So Leabua is not here. Sarwa. Then Kazi. Away to. Camille. Huh? Polisiwe. Christopher. Danica. Casey. And Eminati. Okay. Right. Can I skip? Now you should be finished copying. Okay. So I just want to quickly run through those signs again. When we take a positive times a positive, your answer will be positive. And negative times a negative, your answer will also be a positive. So how I remember it is that if the signs that you multiply are the same, meaning a negative times a negative or a positive times a positive, then your answer will always be a positive. Okay. But this you were taught in grade 8 and actually 7 already. Okay. A positive times a negative will give you a negative. Okay, so let's do two equations. The left-hand side, look at the green one or black one first. So x plus 2 is, x plus 3 is equal to 2. You have got to solve x. What did we do? Last year we said this 3, we take it over and then it becomes minus 3. So I'm going to have x is equal to 2 minus 3. So x will be minus 1. Okay? 2, take away 3, so it's minus 1. Okay. Now you can look at the right-hand side, the blue one. If I've got 2x and that's equal to 12, we have to get rid of that 2. And this is actually 2 times x, right? So if I want to get rid of that times 2, I'm going to divide. Yes, so that's the same as saying divide both sides by 2. And that means that your answer will be 6.
Don't we use that symbol anymore? Division symbol.
Sorry?
Don't we use that division symbol anymore?
Yeah, you could, instead of this, I know some kids like writing it saying x will be equal to 12 divided by 2. And then x is 6. That's also correct. Okay? Any questions yet? Yeah? 12 over 2. Yeah. Yeah. Okay, any other questions? Right, then your homework is exercise 2.2. That's on page 20 and then it carries on 21. So at number 1, you only do BDF. At number 2, only ADF.
Al die singsangleerders moet asseblief nou gedurende pouse en die sal se voorportaal gebruik. Al die singsangkinders, leerders, sal se voorportaal gebruik.
At number 3, you only do BDF, and at number 4, ACE.